Alright, today we're going to continue our work on statistics, and we are going to make dot plots and stem plots of quantitative data, and we'll be able to describe the overall pattern, the shape, center, and spread, as we say, of a distribution, and to identify any outliers that there might be. Okay. So let's look at a dot plot. Frozen pizza. Consumer Reports magazine rated frozen pizza in their January 2011 issue. Here are the amounts of sodium in milligrams in a single serving of 16 different brands of cheese pizza. And you can see 580 milligrams, 740, so on and so forth. So we're going to make a dot plot, and I've already made one here. Okay. It looks like this. You can see 580, we have a dot at 580, 740, a dot at 740 right there. 850, there's three 850s. Okay. This is simply what a dot plot looks like. It's a number line, and you put dots at each appropriate location. Okay, so that's when we make a dot plot. How to examine the distribution of a quantitative variable? Well, as I said, we're going to look at four things. We're going to look at shape, outliers, center, and spread. Some people will call this with a mnemonic device here called SOCS. Look at your SOCS: shape, outlier, center, and spread. Shape. There are several shapes. One is uniform. Doesn't come up very often, but we should know what it is. We have a graph. Uniform would be where it's all the same. This is uniform. Uniform. Then we have symmetric, which the one we prefer is one that looks like this, single peaked in the middle there, and it's symmetric because you can cut it right down the middle and it's exactly the same on both sides. That's an approximately normal graph, which are very important graphs in statistics. Now, not every symmetric graph has to be that. You could have one that has hills like a roller coaster here. That would be symmetric as well, but that doesn't happen nearly as often as our normal, or approximately normal graph, which is very common. Okay. The next type of shape we could have is their skewed shapes, like skewed to the right. Skewed to the right means most of our data is actually on the left, and then on the right we have this long tail. It's skewed to the right because the right is messing up the distribution. If you cover up the right, long right tail, it would look much more symmetric, which is what we would prefer. Okay. And then we have skewed to the left. That should be exactly the opposite. We'd have a long tail on the left, and then something that looked maybe like that as it would come down. There would be our skewed to the left. There's a long tail on the left. Okay. Now, symmetric graphs we've already talked about, like this one that is approximately normal, the normal distribution. Many things in biology, like length or height, the length of a snake, or the length of a cricket, or the height of a person. Now, many of these things are approximately normal. In other words, when it's approximately normal, there's a lot of them in the middle and a few of them on the side. So if we think about height, there are very few people that are very, very short, a lot of people who are about average height, and the very few people that are very tall. And many things in biology, like I said, the height, the length of a snake, the height of a spider, all these things tend to follow this approximately normal shape that we see there. Okay? But there are situations where skewed left and skewed right come up. One, if you think of retiring, what age does a person retire? Well, you're going to have a lot of people up here in your 60s retiring, and only a few people retiring at earlier ages. So that would be skewed to the left, because most of our data is on the right side of the graph, and the skew goes in this long tail that would be on the left. Okay? So center is the next thing we would look at. shape, center, and spread. So center, just the center of the graph. Okay, more later on we'll get into more detailed ways of looking at it, but just look for the center number. It looks like it's the middle number of the graph, or close to the average of the graph for now. And the spread, again, for right now, we'll have more sophisticated ways of measuring spread. It's just how spread out is our data. Well, for now, we're going to talk about what's called the range, which is just the lowest to the highest. That is what we're going to use as spread for now. Okay? And the last thing is outliers. Now, outliers, okay, they don't fit the pattern. They're outside the norm here. So if we go back up here to our dot plot we have for our pizza, you can see it doesn't look like there are really any outliers. But if I came out here and extended out here and made one maybe out here at 1,000, now it's all out here by its lonesome, this would be an outlier. Way away from the rest of the data and you know, hanging out by itself there. That would be an outlier. Sometimes they occur, sometimes they don't. So you never know what's going to happen. Alright. Now here's another example. So look at the number of calories per serving for 16 brands of frozen cheese pizza, along with a dot plot of the data. So here's our dot plot. It says it wants us to describe the shape, center, and spread of the distribution. So the shape, we look, does it look like it has a skew, or does it look fairly symmetric? In statistics, nothing's perfect. It's always going to be approximately symmetric. You know, very rarely is it perfectly symmetric. That doesn't happen. But if I draw a kind of follow the curve of this basic data, that looks fairly symmetric. So the shape is fairly symmetric. Okay, fairly symmetric. It looks like it has a center. If we go up here and look, it looks like the center is right here around 330. So about 330 calories is about the center. And the spread goes from 260 is the low to 380 is the high. That would be our spread. And any outliers, well, we always look at the ends here, and 260 is way off. It's pretty far off there, so 260 may be an outlier. Kind of far away there. Now, stem plots. We're going to create one, and I'll let you create one. Okay. So, who is taller, males or females? A sample of 14-year-olds from the United Kingdom was randomly selected using Census at School website. Here are the heights of the students. You know, we want to make a stem plot, which you may have heard of as a stem and leaf plot. You've probably seen this before. So the stems are everything but the last digit of the number. So we go from the males, it goes from 150 to 180. So we're going to have this. We'll draw a line, and our stems go on this side, and so we have 15, and then 16, those that represent the 160s, 17 for the 170s, and 18 for the 180s. And then we go from order from smallest to biggest. So we look at the males, and their smallest is 151. Okay. And then we have 154, 157, and 159. Those are the 150s. 160, looks like our smallest 160 is 162, followed by 163, and then 165, two 165s, 167, and a 169. Those are the 160s. 170, our lowest looks like it's 174, and then 175, 76, and 77. In 180s, we have 180, 183, and 187. We always should include a key whenever we do this. So our key would be 15/1 equals 151. Let people know what the numbers mean. Now we could talk about shape, center, and spread. It certainly doesn't look like there are any outliers. It's all pretty packed. It looks fairly symmetric. Okay. The spread goes from 151 to 187, and the center is going to be right around 168, 169, somewhere in that range. Now, for the females, we look and there's 152 and 160. There's no numbers in the 170s and there's no 180s. Well, there's only 2 stems then. So if we're going to do that with the girls, a stem of 15 and 16, 2 stems just isn't very many. It's not a lot. It's going to be hard to talk about shape. Okay, it doesn't look. So what we're going to do is split the stem. We're going to do 15 twice and 16 twice. And with the first 15, we're simply going to do from 150 to 154. And then the second 15 will be 155 to 159. All right, so let's see the girls. The smallest one, it looks like, was 152. And then there's 153, another 153. So I see 2 153s. And I don't see any more that are less than 155. So now we're going to move up to the next stem, 155 and above. So I see 157, and then 158, and another 158, 2 of them, and then 159. Now the 160s. Okay, start out with 0, 160, another 160. I have 161 there, 161. And then I'm seeing a 163, another 163, and 164. And then 165 and above, we're going to move up here. Let's see, do we have 165? We do. We have 2 165s. And then 2 166s. 167 I see. 168 and then 168, and then I think we have 2 169s. There's our stem. This is for the females. And again, we'll put a key with that. 15/2 equals 152. So again, we could talk about shape, center, and spread. Again, there doesn't appear to be any outliers. This looks like it might be slightly skewed to the right. It certainly doesn't look symmetric. There's a few on this end and many more over here. So it might be, you might have to say it has a slight skew to the left, actually, because it's skewed to the small numbers. Skewed to the small numbers is skewed to the left. And you could talk about range, 152 to 169, and the center is going to be right around 159, 160 range, somewhere in there. That is how we make a stem plot.